Welcome to Unit 3, Rational Functions, Lesson 4, Graphing Rational Functions. The learning goal today is I can and I will graph a rational function accurately. We talked about this in Lesson 3/4, but today we're going to do some more complicated examples than we did in Lesson 3/4. So here we go. My first example is a quadratic over a quadratic. So we're going to follow the 7 steps. We're going to sketch it as best we can. Step 1. Of course, we're always looking to factor. So step 1, I want to factor it. So here I'm going to have f of x equals 3x minus 2 and x plus 4, a nice complex trinomial, all over a simple trinomial. So here's going to be x plus 2, x minus 4. There we go. Step 2, look for common factors in the numerator denominator. It looks like these are common, but again, one's plus, one's minus, so it's actually not applicable step here. So there's no common factors, which means there's no pinholes, so step 3 is also not applicable. So if you can't do step 2, you can't do step 3. Step 3 says simplify the expression. Of course, there's nothing to cancel out. Step 4, I want to talk about vertical asymptotes. So again, vertical asymptotes just comes from the roots of the denominator. So I've got one here. So I'm going to have here x is equal to negative 2. I also have one beside it. Let's use this, the green. So I've got this guy here. So also x is equal to 4, just the roots of the denominator. So here we go, let's plot those. I've got one right here, and I've got one right here. They're my vertical asymptotes. Step 5 says look at the degree of the numerator denominator, and usually, well, in 2 cases we've got a horizontal asymptote in here. Since they're equal degree, what I do here is I just divide the leading coefficient. So I'm going to divide these two guys here. So again, for here I'm going to have y is equal to 3 over 1, but Mr. Wills, that's silly. Just write it as y is equal to 3. So here we go, y is equal to 3, which is right about here. And there we go. Step number 6. Step 6 says to find the x and y intercepts. So here we go. I'm going to find the x-intercepts first. X-intercepts just come from the roots of the numerator. So right here, so my first x-intercept will be constant over coefficient, so 2 over 3, 0. There's the first one. The other one comes from here, so it's going to be negative 4, 0. And I can actually plot these. Here we go. Negative 2, or 2 over 3, 0. So right about here, and also negative 4, 0, so right about there. Alright, I also want my y-intercepts. My y-intercepts, again, just come from dividing the constants. So my y-intercept will be 0. Negative 8 divided by negative 8 is 1. So 0, 1, so right about there. Alright, let's look at the regions here. In the left region, I only have one point, so I need to find another point here. So I will find another point here. Let's say, f of negative 3. So step 7, I'm going to find some points here to fill in the gaps. So f of negative 3. So I'm going to plot that, f of negative 3, which gives me, should actually find the value before I go to plot it. F of negative 3 gives me negative 1.6. So here I'm going to plot that guy right about negative 1.6. So right about here. And I've got 2 points in this one, so I'm just going to do. There we go. Alright, there's that quadrant. Now this one, the middle quadrant, I would have at least 3 points here because you don't know what it's going. Is it going at like a quadratic, like a nice turning point, or is it just going to go like a negative slope going this way? So what am I going to do here? I'm going to actually find points. 1 point on the left side of this vertical asymptote, and 1 point on the, that's the right side of the vertical asymptote, Mr. Wills. The right side of the vertical asymptote here, and then one side on the left side of that vertical asymptote. So I'm going to find f at negative 1 first. F at negative 1, if I do this quickly, I'm going to have negative 8 here. Negative 8 times 3 is negative 24. So negative 24 on top, and then on the bottom I'm going to have 1 times -5, so I'm going to have -5 here. So what does that give me? That gives me about, actually it doesn't even about, it's about 4.8. So I'm going to plot that. So -1 and 4.8, so I'm right about here. So you can see that there's going to be a cross in that vertical asymptote. It's going to cross it right there. You can cross those middles, that's okay. I'm also now going to find a point at probably f of 3. Let's kind of see what's happening here. F of 3 is -9.8. So here we go. F of 3 is -9.8, so it's right down here. Let's do that in the right color. It's graphing in red, so let's continue graphing in red. -9.8, so it's right about down here. And now I'm just going to connect all 4 of those points. Again, if you've got a vertical asymptote, you want to know what that behavior is close to the vertical asymptote. So it's going to look something like this. There we go. Okay. And I have no points over here, so let's quickly find some points over here. I'm going to find, so you can see there's a lot of finding some values here. Let's do f of 5. Sure. F of 5 gives me 16.7. As you can tell, I've got these values pre-calculated. Why? Because I don't want to waste time actually solving for them, because that's something that you can do quickly. All right, and I also want to do f of 6. So f of 6 is going to give me 10. So I'm now going to plot 6, 10, which is right about here. And now I can just graph something like that. And there is my beautiful function in all its glory.